Is it right or wrong? So if they have the same radius, then there could be a relationship between the volume because they are close to the same shape. I like that one. Okay, if they have the same radius and height, they could be because they're that close to the same shape. I'm not sure if there'd be a relationship between these two. Okay, they have the same. I don't think there's a relationship between the two of them. You might have different ways to solve the problem. The relationship between the two could be the volume of the two because the same height and radius, I think is what they're thinking. No. The relationship would be that on some of these, the cone is taller, yet it's collapsed cylinder.
Collapsed?
Yeah.
I think that because a triangle, because the edges are tilted, so you don't get the actual size of it.
What's the base?
Okay,
so
okay, I got you. So it's collapsed down that way. Is that so? That was yours there. Is that right?
Yeah, that's what I was trying to say.
Okay, thanks. That helps explain. I think there's a relationship. Okay. You might need the radios sometimes to get the volume. Okay. Who's going to take ownership of that one? Okay.
I spelled ratio.
Okay.
No radios.
Okay.
It's okay, it might have been auto.
It's all right, John. It's okay. I mean, this is one of those things. It's a pretty straightforward, just yes or no. There's not a right or wrong, but can you take it maturely, as what it's intended for? That's what it would go into the grade book as. Okay. Okay. So we'll take a look at that and see if there is one or not, and we can determine if we're right or wrong. Finding how much ice cream to put in an ice cream cone, finding out the volume of a clarinet. If you need to know the volume of a graduated cylinder. So that's not too bad. But someone right here, finding the volume of a clarinet. Can you elaborate on that piece a little bit?
Look at that. Miss Steven sometimes asks questions like that.
Okay. All right. Now, and so that might be one where it's pretty far stretched there, Quinn. But I can see the clarinet is a cylindrical shape, and it's going to have a certain amount of air holding capacity, right? Okay. Okay. Okay, so that's that one. Storage tanks, cans, and pipes. I believe that was mine. Water cans, soda cans, cups. Okay. Okay. How about this one? How about this? Okay.
Oh, yeah.
So elaborate on those. Where would a scientist? Do you think a scientist's job is just finding volume of?
You know those little things that they have?
The
Okay.
beaker?
All right.
Yeah.
Now, how about an oil worker?
Oh, you see, pretty good. I thought the oil worker was this. Well, I don't think it was an oil worker. It's where my dad worked. There's this huge cylinder thing, and it holds the thing. I gotta figure out.
Oh, so
Messing with the pretty toys.
Never mind. Okay.
construction worker?
Okay. To find the measurement of an oil filled tank, I like this one. To find the measurement of an oil filled tank. If you're looking for a certain size water bottle, I like that. Putting enough gas into gas tanks at a convenience center. Who right here? Okay, Steve, I like these ones that you put here. They're pretty descriptive on there, and they are all applications. So when you say this one, putting enough gas into the tanks at a convenience center, I'm picturing the guy that's putting the gas into the ground, right? And you're exactly right. If you ever see them, they'll stick a stick down there, and it'll be at a certain height on there, so they know how much gas they're starting with and how much gas they end up putting into that. So, and those are all going to be some sort of different cylinders down there.
That one's my favorite.
Which one? This one I'm on right here. Measuring how much oil could be in an oil tank.
I think there's something about oil tanks.
How much something can fit in a can, filling a cup
my gosh,
Use
Tristan.
ice cream cone? No.
Okay, well, now if we read the question, give at least 3 real-world examples of applying the volume of a cylinder.
Yeah,
This
no.
one here, an ice cream cone has the key word, it has the word cone. Is it even a cylinder?
No.
It's not, right?
That one's not right.
Okay?
That was me.
I know, you were the one who had the oil.
Okay. The engineer team needed to find the volume of the oil intake. Mr. Nielsen has a solid cylinder that would need to be filled to a volume 2. We need to find the volume of
That's true.
the boiler.
Mine's the one.
I did the one with Mr. Nielsen.
This is yours?
Yeah.
That's pretty good. Now, I like this one, the boiler. Now, if you think about a boiler that...
Because it has to hold water to heat the water for your dishwasher, your shower, your tub.
Right. Now,
Washer.
yeah, you're exactly right on there. Now, a boiler, that's going to supply water to a heating system, not so much the water heat. The water heater takes all those other ones, right? So, but a boiler, it's the same thing. You need to be able to determine the volume of all the pipes that you have for a building, and then the boiler
Like
has...
this building.
Yeah, like in, well, it could be a house, it could be a big building, a school,
Skyscrapers.
skyscraper, it could be any of those things. Okay? All right. So those are all some pretty good applications. Can anybody think of any other applications of cylinders?
Yeah. No.
Okay. All right. Now let's take a look and see what this relationship is here. Okay, I think I have enough water here. So we're going to determine. So these guys here, they're more than just the same color. They have some other key pieces that are the same.
Oh, drop.
He broke it.
Okay, so
Is it okay?
So, are we going to get caught up over this thing? Who should give a darn about this?
No.
A school.
I should, if anybody does, right? Okay? So these two shapes